Welcome back. The second video on linear graphs. We're going to be further looking at gradient, or also known as slope. And we denote gradient by the symbol m. And m, what the gradient is, it's equal to the rise over the run. And what that means is how much does it go up? Ooh, can't spell how. How much does it go up divided by how much it goes to the right. Okay, so that's what we mean by rise over the run. And this sort of makes sense that the gradient will be steeper if it goes up more. In other words, if it rises more, it's going to get a higher gradient. So this works out quite nicely. So let's just have a look. I'm going to look at this red line and this green line here. And so we want to find the gradient of each of those out. And so what you do is you pick 2 points on the line. Any 2 points, it does not matter which 2 points that you choose on that line. In fact, I'll go blue. 2 points on this line, and we're going to choose them and see, starting at one point and going to the other point, how much you go across and how much you go up. Okay, so in this case I'm going to start with red. It's easier to choose lines that are on the axes. In other words, if I choose that point there and that point there, they're the 2 points that I'm going to choose. I tried to do blue and it did not do blue. You probably get sick of me complaining about that particular feature there. Okay, so we're going to choose those 2 points. So in other words, between here and here, how much does it go to the right and how much does it go up? That's what we want to know. Now in this case, what we're dealing with is just this sort of like section of the graph here. And what you can often do to try to help visualize it is you can draw a little triangle. So that will be how much it goes across, and that will be how much it goes up. And we're looking at that particular triangle here. So let's have a look at for red. And I've written red in blue. That's really helpful for you, isn't it? So m is equal to rise over the run. This is for the red line. Okay. So the rise, starting from here, we're going to see how much does it go up. Well, let me do the run first. Okay, we'll start from here. The run is 1, 2, 3, 4. It goes across 4, and so 4 is the run. What's the rise? Then we go up 1, 2. So the run is 2. It goes up by 2, and so there you go. It's equal to 2 over 4, which is a half. So this line here, this red line, has a gradient of a half, or 0.5. Okay. And that's how we do it. Now let's just go that again. If we did that the other way around, and say we started at this point here and went and finished at this point here. So let's start at this point here. Let's just see what happens. So m is the rise over the run. And so what we're going to do now, what's the rise? Well, we have to go down by 2. So how much is it going up is what the rise is. So what's the rise? If we're going down by 2, it's actually -2. It's going down by 2. And then we're going this way. We're going 1, 2, 3, 4, but we're going to the left. And run means how much is it going to the right. So what that means is it's going across by -4. It's going to that way by -4. What's -2 divided by -4? That can be simplified again to half, or 0.5. So it doesn't matter which way you do it. You start at one dot that's on the line, you finish at another dot that's on the line, and it doesn't matter which dots you take, it doesn't matter where you are on the line and how far the dots are apart, you will always get the same gradient. That's the thing about linear graphs. So that's how we do it. Let's do the green line. Green line. Again, let's pick some points. I'll get rid of all this because I just want to get rid of all that blue stuff, make it nice and neat. So again, you need to pick 2 points that are on the line. That's the important part to think. And what you're looking for is points that cross over grid points, and I'll show you what I mean, what not to do. So let's get rid of all of that. So let's look at green. What we want to do is pick points that go across lines. So in other words, don't pick like that point there, because it's just floating in the middle. What you want is ones that go exactly over. So like that point there, that's good. That's bad. Other points that are good and bad, that point there, it's not on a grid point. You see it's not on a line, so you don't know exactly what it is. So don't choose that one. Here, that's a good one. That's right on the line and it's on the axes. That's really easy, so that's a good one to choose. So just choose 2 points that are exactly on the grid point. What I mean is exactly on a grid point, not floating around in the empty space in here. Okay, so let's do that. Let's go back and choose 2 good points. And if it crosses over the axes, look at this. It crosses over exactly there and exactly there. I did that on purpose. You know that. Good. So let's have a look at it. I'll draw. There's 2 points on the line. I'll draw my little triangle there and there. And let's have a think about what the gradient will be. Gradient m is equal to rise over the run, and that's equal to. So what we have to do, remember, is start at 1 point. So let's start at this point, finish at this point. What's the map that we need to follow to get to the second point? Right. So let's do the run, even though it's on the bottom. So we go 2 across, 2 to the right. So the run is 2. Let's have a look at the run. The run goes down by 1, 2, 3, 4, 5 units down. And so because it's going down, that's -5. It goes downwards. And so that's your gradient there, -5 over 2. That can also be written as -2.5. That is the gradient of that line. You'll notice if you're a little man on this line, you're walking down, and that means it's got a negative gradient, and there you go, it's a negative gradient, -2.5. And so that's how we find the gradient of lines. Pick any 2 points on the line, start at 1 point, finish at another point on the line, and what is the map from getting from one to the other? What's the rise? What's the run? Okay, so that's good. Let's go to a new page, and I'll just give you another formula for figuring out gradient. So the second way to find out gradient is using this formula. Okay, so what we've got is the second formula, and if we have 2 points on the line, if we know that there's 2 points on the line, x1 and y1 and x2 and y2, this is just 2 pairs of points. Okay, we just give them these names so that we can talk about them in the formula. So these are 2 points that we know on the line. If we know that, then we can just substitute these values into this formula, and that will give us the gradient. Okay, so I'll probably do 2 examples. Let's do one here. Okay, find the gradient between, let's pick some points. Let's just go 3, -5, and let's do -2 and 0. Let's do those 2 points. What's the gradient between those two? Now, what we're saying here is that these 2 points are on the line. So what we've got here, if this is, not going to complain. This is x1, that's your first x value. This is y1, okay? This is your first set of points that you know. Over here, this is x2 and y2, your second set of points over here. And so all you need to do to be able to find the gradient is write out the formula. M is equal to y2 minus y1, x2 minus x1. Okay, so, and now all you need to do is put these values in here. y2, that's this value over here, 0. So it'll be 0 minus, what was y1? y1 is -5. So it's 0 minus -5. So I've got a double negative there, be careful. Here, x2 is -2 here. So that'll be -2. And x1 is 3. So it's x2 minus 3. Like that. Now we just simplify it. What's 0 minus -5? Remember that a double negative becomes a positive. So I've got 0 plus 5. That's equal to 5 on the top line. And then we've got -2 minus 3 is -5. What's 5 divided by -5? That's equal to -1. And so that's your gradient, the gradient of -1. What does that mean? It's got a negative gradient, so it's going that way. If you're a little man, you're walking downhill from left to right. So it's a gradient of -1. Okay, I'll just do one more example. Something like this. Okay, something like this. Find the gradient of this. Now, if you're clever, you could probably look at this and you could go, well, it's just rise over run. If we start at this point, how do we get to this point? And you could go to yourself, well, m equals rise over run. And you'd go, well, that's equal to how much does it, if we start there, we go across by 2 here to get to this point here, so the run is 2, and then you need to go up by 6, and so it's 6 over 2, which is 3, and so your gradient is 3. And that's a great way to do it. I just want to show you just some things to sort of connect a few ideas together. Let's use our formula. M is equal to y2 minus y1 over x2 minus x1. Let's just use this formula as well and check that this is correct. Let's check it. Okay. Firstly, let's just write what this coordinate is. That's the point 6, but let's just write what that's equal to. Okay. So this is actually the point. So that is at 6 there. The coordinates of that point is actually 0. The x value is 0. And the y value is 6. That's the point 0, 6. What's the coordinates of this point here? Well, the x value is -2 and the y value is 0. Okay, so there's our 2 points. And now that we've got that, we can label that as, this is x1. Okay, that's x1, y1, and this is x2, y2. Now it doesn't matter which one you label. I could have labeled this one x1, y1 and this one x2, y2. It really doesn't matter. Okay, so our gradient is equal to y2. What's y2? 0. What's y1? y1 here is 6. Over x2. x2 is -2, minus 2, and negative x1 is minus 0. Let's figure this out. 0 minus 6, -6. -2 minus 0 is -2. What's -6 divided by -2? Positive 3. Okay, so there's 2 ways that you can do it. So in this sort of situation, it's probably better to use the rise over run method. But commonly, when you've been given 2 points, this is a great way to do it. Instead of trying to figure out rise over run, this is a much quicker way. So 2 ways to figure out gradient. Enjoy.